Okay, this lesson here is on conics. So it's kind of an introduction to chapter 9 for us. The reason we put this lesson together is just to kind of show you an overview of what we're going to get into. Obviously, each piece will have independent videos on, but this is kind of, you can come back to this as we go to other videos so you can start to distinguish between one and the other. So it's a good overview. And I also gave you a couple links to other conic videos I found on YouTube that I want you to take a look at. So let's take a look here. Now, what conics means is we have a cone on top of a cone. So let's kind of look at this example right here. And what we're doing is slicing these things different ways. So looking at this cone, notice we have over here parabolas, then circles, ellipses, and hyperbolas. What a parabola is, if you took a plane, so if I took a sheet of paper and I sliced it through the cone, and the piece of paper is parallel. So notice how it's parallel with what? We're talking about being parallel with the edge of the cone. So let me highlight where that would be at, and that's right here. So here's the edge of the cone. The piece of paper that's doing the cutting is parallel to that edge. When that happens, that cross section, that intersection, is a parabola. Okay? And we've studied parabolas before, but now we're going to talk about like where they come from and how to relate it to other conics. Moving on to the next shape, when you have a piece of paper that is perpendicular to the center, okay, so notice it's perpendicular, then you have a circle, which is a nice smooth shape, the same radius. When that piece of paper is tilted and it's no longer perpendicular to the center axis, then you get a circle that is stretched in one dimension, and we call that ellipse, okay? And that's what we have here. Now, hyperbola is when you have either the sheet of paper that is parallel to the axis going down the middle of the shape, or it can be close to parallel, and it actually cuts through both cones at the same time. And what happens there is it's like an exploded ellipse. So instead of connecting, they repel each other and they go in opposite directions. If you notice in the other videos I linked you to, you can show how all three is related just by tilting the piece of paper and showing the different connections. Okay. Now looking at the equations down below, what we have to notice is how do we recognize the equation and match it with the correct conic. When we're talking about parabolas, notice here that we have only one squared term. Okay. So that's one squared term. And notice the other term is to the first degree, okay? So when you only have one square term, that means parabola. We have y equals x squared, and we have x equals y squared. One is a vertical parabola, and the other one's a horizontal parabola, okay? So we're going to talk about both of those. Circles and ellipses are really closely related, and the key is right here. Both are squared terms, and they're added together. The only difference is, in a circle, the radius is the same all the way around. In ellipse, the radius is different for the horizontal and vertical dimension. So we have different values, A and B, down below. And then we set it equal to 1. Okay? Now the difference with a hyperbola is the minus sign. It is very closely related to the ellipse, and there's the two differences. For ellipses and the circles, you see that the x squared and y squared are added together. For a hyperbola, they're subtracted. So those are the things you want to look for. So once again, parabola, you look for a squared term and a single first degree term. For a circle ellipse, you look for both terms being squared and added together. And for hyperbola, you look for both terms being squared but being subtracted. So this is kind of a little introduction to conics. This is a good lesson, again, to come back to maybe after each other lesson to kind of see how it relates to the other ones.